Let's take a look at how negative exponents and radicals relate to the power rule. The power rule summarizes a pattern that we see from the definition of the derivative, which essentially is the following. For any expression of the form x to the n, the derivative of that is going to be n times x to the n minus 1 power. And that's true for any value of n. Negative exponents enter our picture with expressions like 1 over x squared, because an expression like that can be rewritten so that the exponent is negative. 1 over x squared is the same as x to the negative 2 power. And so with that revision, we can apply the power rule, and the derivative would be negative 2, x to the negative 2 minus 1, and so that's the same as negative 2x to the negative 3. In general, x to the n, 1 over x to the n, is equal to x to the negative n. And so if we start with a power expression like x to the n, if we start with a power expression in the denominator, we can turn it into something that we can apply the power rule to by writing it with a negative exponent. One thing to be a little bit careful about, if we have something like 5 over x to the n, that 5 is just going to sit in front. The negative exponent doesn't apply to that. And similarly, if we have 1 over 4 times x to the n, if I convert that, the exponent here, the n doesn't apply to the 4, and so this would be 1 over 4 x to the negative n. Radical expressions can be translated into a form that the power rule works with in a similar way. A radical, like the square root of x, if you think about what that means, the square root of x times the square root of x, well, if I square the square root of x, it just equals x. So let's think about an exponent that I could place next to the x that would do the same thing. Well, exponents add. So if I put an exponent here, this would be the same as x to the n plus n. This would be the same as x to the 2n. So what value of n would give me simply x? N would have to equal 1/2. And so the square root of x is equivalent to x to the 1/2 power. So we could find the derivative for the square root by translating that to the derivative of, not the derivative of the square root, but translating that to the derivative of x to the 1/2. And so that becomes 1/2 x to the 1/2 minus 1. Subtracting 1 gives me negative 1/2, so I get 1/2 x to the negative 1/2. And we could rewrite that as 1 over 2 times x to the positive 1/2, which is the same as 1 over 2 times the square root of x, if we wanted to put it back in the square root form. This same property applies to other roots as well. So more generally, if I have something, the nth root of x, like a cube root or a fourth root or a fifth root, can be written as x to the 1 over n power. And the nth root of x to the m could be written as x to the m over n. Let's look at one more example. Let's take the derivative of the cube root of x. So that's going to be the same as the derivative of x to the 1/3, which is, from the power rule, 1/3 x to the 1/3 minus 1. In this case, I want to think of 1 as 3 over 3, and so then when I subtract it, I get 1/3 x to the negative 2/3. I could write that as 1 over 3 x to the positive 2/3. And to put it back into a radical notation, that would be the same as 1 over 3 times the cube root of x squared. So let me end the video with a question. From what you've seen in this video, think for a moment about how you could find the derivative of 10 over the square root of x. I encourage you to take a few minutes and think about what the derivative of that expression should be. I hope you enjoyed the video. Thanks for watching.